Alright, so the four problems from today's weekly contest. The first problem, minimum positive sum subarray. We are given nums and we are asked to, we are also given two integers L and R, and we are asked to find a minimum sum of subarrays of length between L to R, right? So suppose if L is 2, then the subarray could be this, this, right? If L is 3, then the subarray, I mean, if the size that we are talking about is 3, then this could be 1, this could be 1, and we want the minimum sum among these subarrays, which is positive. So it should be greater than 0. If there isn't 1, then we can return -1, right? So the brute force solution is the first thing that should come to our mind, and that will work as well. But that will be O of n square, I believe. Uh, but we can do better because we can use prefix sum, but that will still go up to O of n into uh, R minus L, right? Because we have to do it. For example, let's talk about this case. Well, let's suppose this is the subarray we're talking about, and we are talking about the sizes varying from 3 to 4 or probably 5. So this is one subarray. Now, if we find out the prefix sum of this entire subarray or an entire array, that will be 1, 3, 6, 10, 15, 21, 28. Right now, we can find the subarray sum of this particular subarray. We can find it for this one as well. We can find it for this one as well. Now, the question is, can we, do the same thing efficiently and include and exclude in a sliding window fashion and do it more efficiently? Probably we can or cannot. I don't think we can, but I won't be surprised if we can as well. So we'll code the first solution, the prefix sum one, which is a little bit more optimized. So first we have to get the prefix sum that will be stored inside this prefix array. Initially, I'll push back 0 to it and then build over it. So for every number, push back element, and that element will be the last element plus the current element, or it should be n. So now the prefix array is done. We'll have an answer initialized with int max. So by the end of the processing, if we still have int max inside answer, then it's time to return -1. And starting from what point? Well, suppose we start from 0 and we go, or probably we start from 1 because prefix will have one extra element, right? It will be of size n plus 1 if size is n, if n is nums dot size. So to take into account of that, we will go till nums dot size. All right, and going for every sizes, right? I'll have j, which will go from L to R. All right. So if I minus j is greater than equal to 0, if they are within bounds, is what I'm trying to say, and I minus j is less than nums dot size, right? In that case, I can find the answer from the prefix only if it is minimum, and that will be prefix of I minus prefix of I minus j, right? Because j will be L to R, and this will give me the subarray sum, and I'll add it only and contribute. It will contribute to my answer only if this particular value is greater than 0, otherwise it won't. So here, if answer is still int max, then return -1, else return answer. There's one optimization that we can do, since one is, it's not making sense, because for the initial elements, initial L-1 elements, it won't be entering this position, because this will bound it from entering. So I can just have L here instead of 1, and I think that will still work. Let's see. Let's submit it. Yeah, this works. Time complexity will be O of n here, of n square. Yeah, my bad. O of n square, because in worst case, R minus L could be as big as n, right? So it will be O of n square. This problem, I don't know why I'm wrong. Yeah, the second problem, rearrange k substrings from to form target string. Hey, we're given S and T, both are strings, and we again an integer k, and we are asked to find if we can divide S into substrings of size, uh, you know, S dot length by k, right? Because basically it is asking to divide S into two substrings, so that would be of size S dot length by k. That's why I said that. And for every division, suppose this is the division, if we can rearrange it and concatenate it like this, rearrangement and then concatenation, it will form CDAB, which is T. If we can do that, then return true. If we can't, return false. So we can just pre-process T and have a map of strings that will store, for every substring, it will store the count, and after that we can just process S and use that map to find if that particular substring is existing in map. If it is, then reduce it from the map, reduce its count, and remove it if it is reduced to 0, the count is reduced to 0, and this way we can just return false and or true based on if we are able to find the strings inside the map. So for that we need a map that will be of size. I mean, you know, the sizes won't be defined. We will pre-process T, so that will be a iteration over T, and since we need to uh, uh, only get the substrings, right, of particular length, so let's get the length. What should be the length? Let's convert K into the length instead of the count of substrings. So this now will, K now represents uh, size of each substring. So since I'll be forming strings of those substrings, right? Let's call this str, initialized with empty string, and my uh, inner loop will go from 0 till k, so that I can just form my substring inside str. That will be nothing but I plus m. Actually, instead of going through every element, I will go and jump over key sizes, and this will form the subs or the string or the substrings of t. And after processing, every substring will be stored here inside the map, and I'll do similar thing for s as well. So let me copy it. I think both will be of equal sizes, so it won't matter. Now I'll form string here as well in a similar fashion. Let me call this m, and this will now be, instead of t, it will be s. At this point, if it exists inside map, uh, in that case, return false right here, else reduce it from the map, reduce its count, check if it is already 0. If it is, then erase it also, so that I won't find it again for the next subsequent substrings if they are equal. And finally, return true, otherwise. Let's see if this works. Time complexity will be O of n, space complexity will be O of n as well. Yeah. The third problem, minimum array sum. Alright, let me reload it. Minimum array sum. We are given a array nums, a integer k, and two integers op1 and op2, and we are told that we can or we are asked to find the minimum possible sum of all elements in num after performing certain operations. And those operations are basically two operations, and this is the number of times we can perform the first operation and the number of times we can perform the second operation. The first operation states that we can choose any number inside nums, divide it by 2, and round it to the nearest whole number, right? That will be basically using it or operating it once, and I can do that only once per index. So one operation can be applied to an index only once, right? But I can apply operation 1 and operation 2 to a single index. That is fine. The second operation states that we can choose an index and subtract k from nums of I, but only if nums of I is greater than greater than k, greater than or equal to k, so that it doesn't go negative. And again, we can only perform this once per index. So we are asked to find the minimum possible sum of all elements in nums after performing any number of operations. So right away, if we look at the constraint, we get an idea. This could be dynamic programming, and we could have a couple of choices. The question itself gave us two choices, and the combination of those two choices can be further extended to solve this problem in a dynamic programming way fashion. I'll be using a top-down approach, but this could be done in bottom-up as well. Uh, so what will be the choices? Well, it looks like it is a take not take program, but with the take there are few couple of options that we can choose. First is not take, that is don't perform any operation. Second is take, and we have couple of options inside. First let's divide, that is divide by 2. Second is multiply, sorry, not multiply, my bad, subtract. Okay. Third is do division, uh, as well as subtraction. So first division and then subtraction. So division, then subtraction, and the fourth one, any guesses? Subtraction and division. First subtraction, then division. Right, so this is the 5 things that we can do, and let's do it. For that we will need a nums array, that is for sure. Key, it is not going to change, so it's not a state. The index, that will be starting from 0. The operations, which is going to be the state, and I think that's it. 3 states is what now suggests that we can minimize it after solving this. To further optimize using a 3D DP, let's create the solve function. The first thing we'll need is vector nums. Since k is not going to change, we can pass it with reference. Index is the third thing. Operation 1 and operation 2 is the fourth and fifth. So at this point, if index is already out of bound, then it's time to return 0. Let's have an answer. Initialize with int max because we want to minimize the answer. So let's have int max so that doesn't affect our answer. So first thing is not take. Well, so if it is not take, then my answer will be either answer or since I'm not taking this, so I'm going to include nums of index as it is inside my answer for the contribution. So let's have nums of index plus solve for the further elements, for the remaining elements. So nums k index plus 1, since we are going to now further operate on the remaining indexes. Second thing, the last thing is operation 1 and operation 2. Since we are not going to use any operation, we are not going to reduce it. This is do nothing. And the third, the remaining will be do something. Let's do it one by one. Divide by 2. So let's divide. Uh, divide only, right? Only. So here, if at this point, since operation 1 is what divide is required, right? So operation 1 should be greater than 0, only then we can apply it, and that will lead to answer to be minimum of answer, or now the weight or the sum contribution will be nums of index And since we are going to divide it by 2 and round it up to the whole number, so it will be a ceiling function, right? Or we can just, since if it's odd, we can just add it. If it is even, uh, it still won't going to affect our answer, right? So we can just add, and remaining can be solved using solve function. Now nums will be nums, k will be k, index will be index plus 1, and operation will be reduced by 1. Operation 2 will be as it is. Now comes the part where we subtract only. Alright, for that operation 2 must be greater than 0. Now my nums of index or the contribution will be nums of index minus k, right? And as it is, but just that operation 1 will be not reduced but 2 will be reduced. Now comes the part where we divide then subtract, right? Divide then subtract. So since we are going to divide it, we can do it right here itself, and that will be only happening if we have a subtract operation remaining. So subtract operation 2 must be greater than 0, and the last thing is the second condition should be what? Since we in the question it's told that if nums of I is greater than or equal to k, only then we are going to use the second operation. So nums of index should be greater than equal to k. Right? Yeah. So that's pretty much it. We can have answer again. This time, since answer it, I should copy this. All right. Why I'm having minus 2 here instead, it should be just reduced by 1, and here as well. Yeah, actually, my bad. There's one mistake here. Since nums of index is going to be divided and then multiplied, right? Then subtracted, right? So my nums of index won't be nums of index, but it will be nums of index plus 1 by 2. I'm sorry. Alright, this is what my current element is after performing the division. Or you know what? Let's not confuse it. Let's write it here itself so that it's more organized and readable, even though the other one was more concise. So let's divide and then subtract. That means this is what we are going to do here. And since the element now is this, so this is what is going to be contributed. All right. Now the last thing is subtract and then divide. So let's copy this and update it. Subtract and then divide. So here, after subtracting, I don't even need to check this first. My operation 1 should be greater than 0. My element or the, yeah, this should be minus k, and now I'm going to perform the division. So plus 1 divided by 2, right? This is the element and the remaining will be as it is, just that instead of operation 2 or instead of operation, yeah, actually here since we are going to divide and subtract, both will be reduced, and I think we are good. We have already handled the do nothing, so I think 5 things. At the end I should return answer. Let's see if this works. We are going to minimize it further. Okay, it doesn't work. This should also be, you know, this is important here. Since we are going to subtract only, we should also check here if nums of index is greater than equal to k, right? Let's see now. I don't think that's going to affect anything. Operation 1. Okay. Here, since we are going to perform both operations, we should check both operations, right? Both should be greater than 0. Here as well, operation 2 should be greater than 0. Let's see now. Yeah. Now let's create the cache. That will be a 3D DP. First thing will be index of size n plus 1. Operation 1 and operation 2 will be also of size. Let's see the constraint. So it can be 100 and this also can be 100. So let's have 101. Let's create the cache. Cache. Let's resize it here. Will be a vector of int. So first state will be the numbers I resize. The second will be operation 1. The third will be operation 2. Initialize with -1. So let's check if cache of index, I'm sorry, index operation 1, operation 2, oh shit, operation 2 not equal to -1, return this and keep updating it every time. Let's submit it. Space complexity will be O of n cube. Okay, there's a mistake. I think somewhere I'm missing the check. Okay, so since we are subtracting, we should also check here as well. Nums of index is greater than equal to k. Right? Let's see now. Okay, it works. Uh, Space complexity will be O of n cube. Time complexity will also be O of n cube, I believe. Since we have three states, index, OP1 and OP2, and all can be, in worst case, of size n. So